So we're going to be learning about linear inequalities today, graphing, and looking at it algebraically also. But for the do now, I just want you guys to graph that equation. Pause the video and play it once you're done. So my y-intercept is 4. My slope is -1/2. Make sure you plot every single point so you can be precise. Connect all the dots. Arrows on the end, extends all the way through, and label your line. And there it is. You also could do an XY table if you want to. You don't have to. You could just look at the slope and the y-intercept, but either way is perfect. So, the big thing about linear inequalities is it's very similar to graphing equations. So if I actually wanted you to graph y is greater than or equal to -1/2 x plus 4, it's the same process. So you still would graph the same exact line, the same exact way you did. So y-intercept of 4, slope is -1/2. Plot all those points. Oops. Plot all those points. Make sure it goes through every single point. Arrows on the end. And this is the main difference. It's greater than. It's an inequality. So if you remember from last year, we have to shade. So there's a couple different ways of shading. So you can either shade if it's greater than, you shade above the line. If it's less than, you shade below the line. And if you're wondering what above and below the line is, I sometimes get confused by that also, especially when the slope is really steep. Just make the line with like your arm. Make it go the exact same way as the line is. And then if you move your arm up, it shades up. If you move your arm down, that's shading down. So we're greater than, so we want to shade above the line. So it would look like this. Another way you could do, and you might have done this way last year, was you could plug in a point on either side of the line. So I always try and plug in 0, 0 when I can, because zeros are the easiest number to work with. And if you take a look at this, it's on the bottom, it's underneath the line. So it's not on the line, it's underneath the line. So it's on one of the halves. So I'm going to plug in 0, 0 in for x and y. So I have 0 is greater than or equal to -1/2 times 0 plus 4. When you simplify that, you get 0 is greater than or equal to 4. That is not true. So we do not shade on that side. We would shade on the other side. And you see both ways give us the correct shaded region. Now, how about if it was y is less than -1/2 x plus 4? I want you guys pause the video, try and graph this by yourself. There's one major mistake I see a lot, so be careful and pause the video and play it once you're done. So for this one, same exact beginning, we still want to just graph the equation. Make sure it goes through every single point. Arrows on the end. And then you might have guessed it. It's less than. So if it's less than, we want to shade down. So I shade underneath the line, below the line. But there's one major difference. In the previous example, our symbol was greater than or equal to. So it could equal what's on the line. So our line is a solid line. But in the case we are having right here, it's not less than or equal to, it's just less than. So you got to not have a solid line, but you're going to have a dotted line. And that shows that you can't have any of the actual answers on the line. So no answers can actually be on the line because it can't be equal to the line. It has to be less than the line. So you just want to dot or dash, whatever you want to call it, the line. And this shows that if we get a point that's on the line, it's not going to be an actual solution. And I could show you guys why. So let's plug in a point that's on the line. Let's plug in the y-intercept. That would be 0, 4. If I plug that into our inequality, so 4 is the y, 0 is the x, I end up getting 4 is less than 4. 4 is not less than 4. That is not true, so it shouldn't be a solution, which is why we have a dotted line. So that's what we're doing. We're just looking at linear inequalities, and the next half of the notes is looking at systems of linear inequalities. So when we're doing, when we're graphing two of them at the same time and shading both to see where it's shaded, the double shaded region. So for the first one, let's take a look at algebraically determining. So I want you guys to take, actually, take 3 to 5 minutes. I want you guys to do algebraically determining if that's a solution, and also graphically determining if negative 2, 6 is a solution to this inequality. So pause the video, play it once you're done. So if I want to algebraically prove the point is a solution, we just got to plug it in, much like we were doing above. We were just plugging in a point there to see if it was a solution. So negative 2 is the x, 6 is the y. Let's plug that in. So 6 is the y, and negative 2 I plug in for the x. I always use parentheses so I don't make any potential mistakes. We get 6 is greater than negative 4 plus 7, which is 6 is greater than 3. This is true. So negative 2, 6 is in the solution set. And now we have, it says explain your reasoning, so you have to actually put words to it. You can't just show. If it said justify, you can just show your work, but it says explain your reasoning. So why is it in the solution set? Well, let's see. You can say a couple different things. I'm just going to say it makes the point when plugged into the inequality makes the inequality too true. So the point when plugged in to the inequality makes the inequality true. Now let's take a look at graphically. So graphically determine if negative 2, 6 is a solution to the same inequality. So it should be in the solution set. So first thing we want to do is graph our inequality. So our y-intercept is at 7, and our slope is 2. Up 2 to the right 1. Make sure it's a positive slope. Now it's y is greater than, not y is greater than or equal to. So we can't equal what's actually on the line. So make sure you dot that. That is the number one mistake I see every single year with graphing inequalities, is that people always tend to just keep that line solid. If it's less than or if it's greater than, it cannot equal the line because it's not less than or equal to or greater than or equal to. So you have to make sure you dot or dash the line. Okay, so it's y is greater than, so we want to shade above the line. So it should look something like this. Or you can test a point. That's fantastic. You can actually test negative 2, 6 if you want to. And then negative 2, 6 would be right here. And that's in the shaded region, so that is a solution. So negative 2, 6 is a solution because it's just in the shaded region. It is in the shaded region. So algebraically, you plug into the inequality. Graphically, you graph the line and see if it's in shaded region. So I want you guys to pause the video and just do this checkpoint 1, 2, A and B, and then also all of 3. This should take 5 to 10 minutes, so don't rush and play the video once you're done. Here's what I got for 1. For 1, just take a look at the slope. It's 2. Y-intercept's -3. And then the big thing is it's shaded above the line, so it's greater than. And the line's also a solid line. It's not dotted, so that's why we have greater than or equal to. There's 2a and 2b. That's line y is equal to 3, but y is less than 3, so you want to shade below, and it can't equal it, so you dot the line. And then for number 3, the main thing here is after you write your inequality, you have to graph it. So to graph it, we have to get the y by itself. We want to get into y equals mx plus b form. Or it's not equals because it's inequality, so in this case it would be y is less than mx plus b form. And now we can graph it. So we can see the rate of change is -3/5, and the y-intercept is 8. So this is how our graph should look. And there's a couple ways of answering the last question. I did it graphically, so I said the highest amount of matinee tickets we can have is this right here, which would be 13. But you also could have done it algebraically. Matinee tickets is the x. So if you plugged in 0 for y and it said 7.5x plus 12.5 times 0 is less than or equal to 100, you would end up getting 7.5x is less than or equal to 100. And you could divide by 7.5 on both sides. And you'd end up getting x is less than 13 point something. And that you can't get the 14 because it's less than or equal to 13. So the highest amount you can get is 13 matinee tickets. So I want you guys to take 3 to 5 minutes, pause the video, and complete the do now 1, 2, and 3. And play it once you're done. So we have y is greater than 1/2 x minus 2. So I'm going to plot it like a normal line. Y-intercept's at -2. Oh. And then my slope is up 1 to the right 2. Plot as many points as you can. Draw your line. Arrows on the end of it. Now it's greater than, it's not greater than or equal to, so that's when we know it can't equal what's on a line. So how we denote that is we do a dashed or dotted line. So make sure you dot your line or dash your line. I'm sure some of you guys forgot to. It's the number one mistake I see. So please remember, if it's greater than or if the sign is also less than, you have to dot the line because it's not equal to. So we dot our line. And now it's greater than, so we have to shade up. And now we have to also do the same thing for the second equation. But taking a look at the second equation, why can't I graph it how it's written? Well, I mean, I guess you could if you want to do an XY chart. But you have to get the y by itself to make it a lot easier on yourself. So I'm going to add 8x on both sides. 4y, getting the y by itself equals 8x plus 20. And now I divide by 4 to get the y by itself. And that'd be y is less than or equal to, make sure you divide everything in the numerator, each term in the numerator, by the denominator. So that would be 8x divided by 4, which is 2x, plus 20 divided by 4, which is 5. So my y-intercept is 5, and my slope is up to the right 1, positive 2. So this is my line. Connect all the dots. Arrows on the end. Make sure you label both also. Almost forgot to do that. Y is less than 1/2 x minus 2. And also make sure you shade the inequality for number 2. So it's y is less than or equal to, so it's going to be going underneath the line. You could test a point too if you want to. And I just always make sure to put an S in a double shaded region just because you don't need to if it's obvious enough, but it just it's nice to make sure that the grader can see that that's the solution set. So name a solution in the system of inequalities, and all you need to do for that is just name a point in this region, any point, and do a point that's kind of obviously in the region in case you make a mistake and you plot the slope wrong or something like that. You could still have this be correct. You see how that one is clearly right in the middle of the double shaded region. So that's what I would do. So that would be the point 7, 8. Be careful with this. You do not want to say a point that's on the dotted line, like this point right here, because that's actually not a solution. If it's on the dotted line, it can't be equal to the dotted line. The dotted line is a bunch of open circles. So that would not be a solution. So that's why I say always make sure you just have a nice point somewhere in the middle here. So in case you plotted anything incorrectly, you can still get that correct. Awesome. So the key to this next question that we're about to do is we're going to have to solve for y, much like we did in number 2 here on the do now, for both equations and then solve. So make sure you're good with that. And before you start the next one, I want you guys to think. First read the question and then think what is the x and the y. So pause the video and play it after you have thought what the x and y is. It doesn't actually tell you in the wording of the question. It tells you on the actual axes of the graph. So the computers is y and printers is x. So be careful with that. Pause the video, complete this question now, and we'll go over it when you're done. So please pause the video and play it when you're done. I wrote let statements for let y equals computers, let x equal number of printers, and you'll see here are my 2 inequalities I got, but then you have to solve them. You have to solve them because, well, how do I get those inequalities? Well, at least means you can have greater than, but you also could have it equal to 2,500, so that's my first inequality. And then maximum of 15 means I can't have more than 15. 15 is my maximum. So x plus y would be less than or equal to 15. You solve for the y in both of them. You graph them, make sure you label it. Double shaded region in this case, blue and yellow makes green, so I put as a solution set. And determine a number of printers and computers that would allow the electronic store to meet all constraints. Just name a solution in a double shaded region, the solution set of both inequalities. So I said 6 printers and 7 computers because that's in the double shaded region. You also could say that 6 printers and 7 computers, or any point in the double shaded region, meets the constraints of both inequalities. You can plug them in algebraically. So that's it. There's a bunch of practice after this.